Good morning. Welcome back to Extended Algebra. Today we're going to talk about systems of equations. Some of you are going to notice that this is very familiar. This is what we did last spring, as long as you were caught up and doing well in the first couple of units. But we're going to go through this again. Make sure you're set with it because it is something that comes up in Algebra 2. The first unit, our first topic in the unit is graphing systems of inequalities, or sorry, systems of equations, and kind of going from there. So before we do anything, this problem is in your packet. It is on Realize as an activity or in the book online on page 143, so you can use that if you'd like. And what I want you to do is read this problem, go through and kind of type in your responses here for these questions. Once you're done, you could submit, and then you'll see my answers. Okay, here are my solutions. Leo is going at 12 miles an hour, so his total distance is going to equal 12 times x, where x is the number of hours. Juan is going at 15 miles an hour, so 15x would give the speed, and then 15 times h would be the number of hours after he starts after Leo. Once you have those, you can graph those equations, and y equals 40, and then the first person to hit 40 would be the first to finish. And then how much of a head start must Leo have to finish the trail at the same time as Juan? Well, if Leo's going at 12 miles an hour, we can figure out that it's going to take him 3.3 hours, which is about 3 hours and 20 minutes. So if I plug that in for my time here to figure out what the h is, and distribute and solve, I find that it's 0.6 repeating hours, which is 2/3 of an hour, or 40 minutes. So if Leo had a 40-minute head start, he would finish at the same time as Juan. Okay, systems of equations is a set of two or more equations containing two or more variables. We're focused on two equations with two variables. You will build on that in Algebra 2. The solution is an ordered pair. It is extremely important to remember that your ordered pair has the x value first and then the y value. You must have both to be able to write your answer down. And then I'm not so worried about classifying the system, but you do need to know that there's a case where there's one solution, there's a case where there's infinitely many solutions, and there's a case where there's no solution. Okay, so here's what we're going to do. What is the solution to the system of equations? Off to the right. Your first step there is to graph both equations. So in your notes, go ahead and fill that in. Graph both equations. So I'm going to do that using red and blue. Hopefully I'll do my best there. So -4 is where we start. 1, 2, 3, 4, always on the y-axis, and then go down 2 over 1. So hopefully this is coming back from last year. Down 2 over 1, down 2 over 1. And I can draw a nice straight line in there. I highly recommend using a ruler or the edge of an ID or something like that. So I'm going to switch that to red so we know that it is the first line. And remember that your lines should have arrows on both ends and they should stretch all the way across the graph. I will tell you that if you don't have nice straight lines, it could affect your answer in here. The second equation, we start at 6. So 1, 2, 3, 4, 5, 6. And then I'm going to rewrite this. 0.5 is the same as 1/2. So this is telling me to go up 1 over 2. And I am going to draw in a straight line there. And I'll change that to blue. With my arrows at the end. Okay, and now you'll notice that when I'm done with that, there's a point where they cross, and that's really close to here. I'm going to approximate that, but I'm looking at this value right here. Okay, so once you have graphed them, the second step is to find the point of intersection. Okay, so this is at 1, 2, 3, 4, 1, 2, 3, 4. So -4, -4 is what I believe, sorry, -4, +4 is what I believe my solution is. And then step 3 is to check it in both equations. So remember, this is x and this is y. So for the first equation, we're going to have 4 equals -2 times -4 minus 4. So if I check this, I get 8 minus 4, which is 4. So it works for the first equation. And then for the second equation, we're going to have 4 equals 0.5 times -4 plus 6. This is -2 plus 6 is 4. So it works for both. So our solution is -4, 4. Apologize for that negative sign there. I'm going to stop this here. There is a try it problem online or on page 143 in your book, and you will type your solution in when you are done. Okay, second set of problems, A and B. For A, to graph this line, for my first step, we use the cover-up method. So if I cover up my y, I'm left with 15x equals 25. So if I divide by 15 on both sides, I get 5/3, which is about 1.67 repeating. And then cover up my x, I get 5y equals 25. So if I divide by 5, I get 5. My x-intercept is about here. My y-intercept is about here. And I can draw my line. Okay. Put arrows at the ends and you are good. Okay, the next one's in slope-intercept form if you change that so that your x is first. So I'm going to start at 5. 1, 2, 3, 4, 5. And I'm going to go down 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Now, hopefully you're noticing that that second line that I just drew goes right on top of that first line. When this happens, that means that they're always touching and that they're depending on each other. Okay, so wherever one goes, the other one goes. This is a situation where we have infinitely many solutions, and you can actually write infinite solutions for your answer there. For the next one, in standard form, I cover up my y. I get -2x equals 6. So if I divide by -2, I get x equals -3. So 1, 2, 3. And if I cover up my x, I get y equals 6. So 1, 2, 3, 4, 5, 6. And I can go ahead and draw my line. And I'm going to make that blue. Okay, for the second one, we're going to use the cover-up method. If I cover up my y, I get -4x equals 8. So if I divide by -4 on both sides, I get -2. So -2 is right there. And then if I cover up my x, I get 2y equals 8. So if I divide by 2 on both sides, I get y equals 4. So 1, 2, 3, 4. And then if I go ahead and draw my line, nice and straight through those two lines, you're going to notice that I have parallel lines. Well, if we don't ever cross, we cannot find a solution. So this is a case where we have no solution. So you can write no solution, or you can type in or write in empty set. Okay, there is an additional example online if you want to check this out just to get more help. Otherwise, try it problems and type your answers in. Okay, this last one is the 3.0. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Monisha both maintain the reading plan, when will Holly catch up with Monisha, and who will finish reading the novel first? So our information is over here. We're going to write an equation for Monisha, and we are going to write an equation for Holly. So for Monisha, she has read 96 pages and is reading 9 pages per day after that. And Holly has read 6 pages and is going to read 20 pages per day. So to graph this, we really need to go by like tens here to make sure it fits. So 1, 2, 3, 4, 5, 6, 7, 8, 96 would be right here. And that's a really big graph. So what we're going to do is we're going to step away, jump into Desmos.com or the Desmos app, and I put my 2 equations in here. So I have my red line and my blue line. And if you click right here, it tells you right where they intersect. So 8.182 and 169.6. Now notice the first person to get to 220, which is right here, is going to be the blue line, or Holly. Okay, so we're going to answer both of those questions. Let's flip back here. So Holly's going to catch up after 8.182 days. And she will finish first. Okay, again, there's an additional example if you want to check it out, and then you're going to complete the try it problems. This is what you're going to need to be able to do to get a 3.0 on this assessment. Okay, here are your assignments. You have options. You can do the MathXL website, the problems on the website, and enter those on the website, or you can look at the book on the website and do these problems on paper. There are graphs at the end of this. When you finish this 4.1 lesson quiz is simply to check how you're doing. If you have any questions, please do not hesitate to ask. Have a great day.